Socratic Math Tutor here. Let's finish off our times tables. So hopefully you watched the previous video, and if so, that means you know how to explain 2 times a small number, 3 times a small number, 4 times a small number, and 5 times a small number. And of course, multiplying by 0 and 1 is always very easy to explain. So that actually carves out a big part of our times table that the student now doesn't have to memorize because they have strategies for actually doing the products, right? So, for example, anything left of this, left of 6 is quite easy because one of the two numbers will be 5 or less. Similarly, anything above this line is quite easy. So, for example, suppose we're trying to work out this product. So this is 4 times 7. And because 4 is less than or equal to 5, the student can do that. They can do that quite easily. And similarly over here, suppose we're doing this number. So this is 8 times 3. Again, because 3 is 5 or less, therefore the student can easily work out that product. So if you think about it, we've actually covered a big part of this table. I mean, we've covered all of this. We've covered all of this. We've done all of this. And so the only part left to really think about is how we explain this portion. So I've gone and put all the products we still need to teach over here in this table. And so the idea is basically that if this number is strictly greater than 5 and this number is strictly greater than 5, well, then the product can't be worked out using any of those techniques that we just spoke about. So this is obviously a lot better than memorizing the full times table, but it's still far too big. I mean, 16 products is a lot to memorize. So what we're going to do now is we're going to talk about multiplication by 9. And what that's going to do is it'll get rid of this column and this row as well. And therefore, all we'll have to deal with is this table here of 9 products. And we can give a specialized strategy for this table, and multiplication by 9 will deal with the rest. So let's have a look at how to do 9 times any single digit number. So for example, 9 times 4. So what you do is you just reduce the 4 by 1. So the 4 becomes a 3. And then you want to break up 9 as 3 plus another number. So in this context, that extra number would be 6. And therefore 9 times 4 is 36. So go ahead and just give the students problems like 7 times 9. They're expected to circle the 9 because that's giving them the strategy. And then they should reduce the other number by 1, write it down, and then find an extra number to put right at the end so that the sum of these two digits equals 9. So with that in mind, there's only these 9 single-digit products left. And to be honest with you, I kind of lied in the title. So I said without memorization. The truth is there's a tiny bit of memorization in this technique, but it's much, much less than learning the whole table. And in fact, we're not going to memorize all 9 of these products, and we're not going to ask the student to memorize them. But what we're going to do is we're going to focus on the squares. So in particular, hopefully the student can memorize that 6 sixes are 36, that 7 sevens are 49, and that 8 eights are 64. So in general, I do actually recommend that all the square numbers be memorized, up to maybe 16 or 17, something like that. In this context, we only need 6 through to 8, but I actually think students should memorize all of their square numbers up to say 16 or 17. In any event, for the purposes of this video, these will be sufficient. And the idea is basically to use these together with skip counting to figure out the rest of this table. So what do I mean by skip counting? What I mean is that the gaps here are always 6. 6's there, 6's here, and the gaps here are 7. And so therefore, as long as we know what these square numbers are, we can then add either 6 or 7 the right number of times to find all the other products. So for example, suppose the student is faced with 6 times 7. They know 6 sixes are 36, and therefore using skip counting, they know that they should add 6 to that number to get 6 times 7. So the answer is 42, right? Because from 36, we need to add 6 to get to 42. Now, regarding how to actually teach this, first you want to teach these squares, these 3 very important squares, and then you want to give the student problems like this in which the expectation is really that they're going to circle the smaller of the two numbers, and then they're going to tell you what the square is, and then they're going to skip count up from that square to get the actual number. So, for example, if you give them 7 times 8, the expectation is that they're going to circle the 7, they're going to tell you what 7 squared is, so 7 squared is 49, and then they should add 7 to that in order to get 56. Now, if you want to be lax, you don't have to get them to announce the square for you. It's enough to just circle the appropriate number, namely the smaller of the two. But if you really want to test them, get them to firstly announce the square and then to work out the answer. So let's go ahead and summarize the full algorithm. So it's really this simple. Suppose we're given a product of single-digit numbers, like 6 times 7. First, we ask whether one of the numbers is either in here or in here. If at least one of them is in there, we have a trick for working out the product. In this particular case, we don't have a trick. So therefore, we move to phase 2 of the algorithm. We focus in on these 9 products. And in particular, what we need to do is we need to look at our numbers and circle the smaller of the two. We've memorized the square of that. In this case, it would be 36. And therefore, using skip counting, we can get our answer. And it really is that easy. So don't teach students to memorize their times tables. There's a tiny amount of memorization necessary. And if you've done that, and if you know the tricks, you can work out any single digit product almost as quickly as if you had memorized it.